this video, we are going to solve problems regarding conversion of units. For our first problem, starting with the definition of 1 inch is equal to 2.54 centimeters, find the number of A. kilometers in 1 mile and B. feet in 1 kilometer. Our given is 1 mile and 1 kilometer. We are required to convert miles to kilometers and kilometers to feet. For our equation, we identify our conversion factors. For every 1 inch, we have 2.54 centimeters. For every 1 kilometer, we have 1,000 meter. Our 12 inches is equal to 1 foot and 1 mile is equal to 5,280 feet. Let us plug in our conversion factors to our solution. For letter A, we have 1 mile is equal to, so we multiply our conversion factor for miles to feet. We have 5,280 feet in 1 mile. Next, we multiply our conversion factor for feet to inches. We have 12 inches in 1 foot. Then we multiply our conversion factor for inches to centimeters. We have 2.54 centimeter in 1 inch. And we multiply our conversion factor for centimeters to meters. For 1 meter, we have 10 to the power of 2 centimeter or 100 centimeter. Next, we multiply our conversion factors for meters to kilometers. We have, for every 1 kilometer, we have 10 to the power of 3 meters or 1,000 meter. So what we're going to do is to multiply 1 mile with 5,280 feet divided by 1. Here we cancel out the unit for mile. Next, we are going to multiply 12 inches divided by 1 foot. We cancel out our unit for feet. Then we multiply to 2.54 centimeters divided by 1 inch. So we cancel out the unit for inch. Then we multiply to 1 meter divided by 10 to the power of 2 centimeters or 100 centimeters. Here we cancel out the unit centimeters. And lastly, we multiply it to 1 kilometers divided by 10 to the power of 3 meters or 1,000 meters. We cancel out the unit for meters and the answer is 1.61 kilometers. For letter B, 1 kilometer is equal to, so we multiply 1 kilometer to the conversion factor, kilometers to meters. We have 10 to the power of 3 meters or 1,000 meter in 1 kilometer. Then we multiply the conversion factor for meter to centimeter, 10 to the power of 2 centimeters or 100 centimeter in 1 meter. Next, we are going to multiply the conversion factor for centimeters to inches. For every 1 inch, we have 2.54 centimeters. Lastly, we multiply the conversion factor for inch to feet. For every 1 foot, we have 12 inches. So we are going to multiply 1 times 10 to the power of 3 or 1,000 meter divided by 1 kilometer. Cancel out the unit kilometers. And we multiply 10 to the power of 2 centimeter or 100 centimeters divided by 1 meter. Cancel out the unit meter. Next, we are going to multiply 1 inch and then divide it by 2.54 centimeters. Cancel out the unit centimeters. And lastly, to multiply the answer to 1 foot divided by 12 inches. We cancel out inches. We are left with the unit feet and the answer is 3.28 times 10 to the power of 3 feet. Final answer, A, we have 1.61 kilometers and B, 3.28 times 10 to the power of 3 feet. Next problem, how many nanoseconds does it take light to travel 1 feet or 1 foot in vacuum? So we have here a picture of light traveling at a length of 1 ruler or 1 foot. Our given, we have the distance of 1 foot Also, we have to take note that the speed of light is equal to 3.00 times 10 to the power of 8 meters per second. We are required to convert feet to meters and seconds to nanoseconds. In our equation, we take note of our conversion factor. For every 1 foot, we have 0.3048 meters. And for every 1 second, we have 10 to the power of 9 nanoseconds. We have to remember that the equation for velocity is displacement over time. Here we can derive the formula for solving time, which is equals to displacement divided by velocity. So for our solution, we're going to use the equation for time. Time is equals to displacement divided by velocity. So displacement of 1 foot, we have 0.3048 meters divided by the velocity of light, which is equal to 3.00 times 10 to the power of 8 meters per second. And our final answer here is 1.02 times 10 to the power of negative 9 seconds. Here we are asked for the unit of time in nanoseconds. So we need to convert 1.02 times 10 to the negative 9 seconds to nanoseconds by multiplying it to the conversion factor. We have 10 to the power of 9 nanoseconds for every 1 second. So our answer here is 1.02 nanoseconds. Our final answer is 1.02 nanoseconds. For our third problem, the density of gold is 19.3 grams per centimeter cubed. What is this value in kilograms per cubic meter? Our given for the density of gold using the symbol ρ is equals to 19.3 grams per centimeter cubed. We are required to convert grams to kilograms and centimeter cube to meter cube. For our equation, we have the conversion factors. 1 kilogram is equal to 1000 gram. And for every 1 meter, we have 100 centimeter. Let's plug in our conversion factors to our solution. We have 19.3 grams per centimeter cube. We multiply that to the conversion factor for grams to kilograms. For every 1 kilogram, we have 1000 gram. And then we multiply it to the conversion factor for centimeters to meters. So we have 100 centimeter in 1 meter. Here we need to raise the quantity to the power of 3 in order for us to cancel out the units for cubic centimeter. So we multiply 19.3 times 1 kilogram divided by 1000 gram. Cancel out the unit for gram. Then we multiply our answer to 100 centimeter cube divided by 1 meter. Cancel out the unit centimeter cube. Cube of 100 is 1 times 10 to the power of 6. So here our answer is 1.93 times 10 to the power of 4 kilograms per meter cube. For our final answer, we have 1.93 times 10 to the power of 4 kilograms per meter cube. For our next problem, the most powerful engine available for the classic 1963 Chevrolet Corvette Stingray developed 360 horsepower and had a displacement of 327 cubic inches. Express this displacement in liters by using only the conversions. 1 liter is equal to 1000 cubic centimeter and 1 inch is equal to 2.54 centimeters. Our given is the volume or the displacement of 327 cubic inches, and we are required to convert cubic inches to liters. Our equation, our conversion factor, 1 liter is equal to 1000 cubic centimeter and 1 inch is equal to 2.54 centimeters. We plug in our conversion factors, 327 cubic inches multiplied with the conversion factor, inches to centimeters. We have 2.54 centimeters for every 1 inch. We raise this quantity to cube or to the power of 3 in order for us to cancel out the unit for cubic inches. Then we multiply the conversion factor for cubic centimeter to liters. For every 1 liter, we have 1000 cubic centimeter. So we have 327 times 2.54 divided by 1 times 1 divided by 1000. The answer here is 5.36 liters. So for our final answer, we have 5.36 liters. For our last problem, the following conversions occur frequently in physics and are very useful. Let's have letter A. Use 1 mile is equals to 5,280 feet and 1 hour equal to 3,600 seconds to convert 60 miles per hour to units of feet per second. So we have a given a velocity 60 miles per hour and we are required to convert miles per hour to feet per second. For our equation, we take note of our conversion factor. 1 mile is equal to 5,280 feet and 1 hour is equals to 3,600 seconds. Next, we plug in our equation or our conversion factors to our solution. We have 60 miles per hour multiplied with the conversion factor miles to feet. We have 5,280 feet in 1 mile. And then we multiply the conversion factor for hours to seconds. For every 1 hour, we have 3,600 seconds. So we multiply 60 times 5,280. We cancel out the unit for miles. Then we multiply our answer to 1 and then divide it with 3,600 seconds. So we are left with the unit feet per second and our answer is 88 feet per second. Next, for letter B, the acceleration of a freely falling object is 32 feet per second squared. Use 1 foot is equals to 30.48 centimeters to express this acceleration in units of meters per second squared. So our given is the acceleration of the freely falling object due to gravity, which is equal to 32 feet per second squared. And we are required to convert feet per second squared to meters per second squared. For our equation, we have the conversion factor 1 foot is equal to 30.48 centimeters. Let's plug that into our solution. 32 feet per second squared multiplied with the conversion factor for feet to centimeter, we have 30.48 centimeter in 1 foot. And then we multiply that to the conversion factor for centimeters to meters. So we have, for every 1 meter, we have 100 centimeter. So we multiply 32 times 30.48 divided by 1 foot. We cancel out the unit of feet. Then we multiply that answer to 1 and then divide it with 100. We cancel out the unit for centimeters. We have the answer 9.8 meters per second squared. So our final answer is 9.8 meters per second squared. For letter C, the density of water is 1 gram per centimeter cube. Convert this density to units of kilograms per meter cube. So we have the given, the density of water, which is 1 gram per centimeter cube. And here we're going to convert grams per centimeter cube to kilograms per meter cube. Our conversion factor, for every 1 kilogram, we have 1,000 gram. And for every 1 meter, we have 100 centimeter. For our solution, we multiply 1 gram per centimeter cube to the conversion factor of grams to kilograms, we have for every 1 kilogram we have 1000 grams. Then we multiply the conversion factor for centimeters to meters. So we have 100 centimeter. We need to raise this quantity to the power of 3. We take the cube. So here we have 1 times 1 kilogram divided by 1000. We cancel out the unit for gram. Then we multiply our answer to the cube of 100, which is 1 times 10 to the power of 6, and then divide it by 1. Then we cancel out the unit centimeter cube. So we are left with the unit kilograms per meter cube. So our answer is 10 to the power of 3 kilograms per meter cube. That's it for our video. I hope you have learned something.